Welcome to the virtual classroom. In today's session, we are looking into the Unit 1 in Computer Networks, presented by myself, Dr. G.S. Bapiraju, Professor Department of CSC. And this the part 1 deals with uses of computer networks. Now, what is a computer network? A computer network is a group of computers connected either through wired connections or wireless connections. They use a set of common communication protocols for the purpose of sharing resources located on or provided by the network nodes. Computers on a network can be a part of a group or a domain. The main difference between workgroups and domains is how the resources on the network are managed. We have illustration here. You can see in case of peer-to-peer means workgroups, all the clients are connected and they can share the documents or files within them. And in case of client server, you have a dedicated server which caters to all the clients. Now we look into the features of workgroups. All computers are peers and no computer has control over another computer. That doesn't have a dedicated server. Typically, there are less than 20 computers. A workgroup is not protected by any password. Individually, the system may have a password. And all computers must be on the same local network or subnet. If they are a different network, and they can't communicate to each other in case of workgroups. And coming to the client server, network administrators maintain a server which stores a central database. Domains users can access this database with their password credentials, which are provided by the administrator. There can be thousands of computers in a domain, and the computers can be on different local networks or on a different subnet. They can still share the things and they can communicate with the server. Now, what is a domain? A domain can be a single server or it can be a group of server computers that share a common user account database. Normally, this will be under a single administration. And now coming to the uses of computer networks. The first one is hardware sharing. In a network environment, each computer can access and use one or more hardware devices or peripherals connected in the network. Suppose an organization have expensive printers or scanners or any special peripherals. If they once they connect in the network, all the users can share it. All the users can use it. So we have example here: printers, scanners, routers, etc. And coming to software sharing, this is another very important application in client-server based technologies. Instead of installing software in each and every system, you can install this application software on the central server, which can be accessed by the clients. So this avoid having to install a copy of the program on each worker's computers. So example, you have spreadsheets, word processing programs, antivirus, so on and so forth. And sharing of data information. In a network environment, any authorized user, by using his credentials, they can access the data information stored on other computers in the network. Users can also access central database for real-time applications. For example, online ticket booking, as well as e-commerce applications where you will buy products and even bank transactions. Now, if you look at the types of transmission, there are three types. One is unicast, where a single system communicates with another single system point to point, and a broadcast, where a single system communicates to all the systems in the domain, and a multicast. In case of multicast, a single system, it only comes with a group of computers or a group of users. So normally when they use multicast, they have to first divide the groups and then only they can implement this multicast. Now, part 2, types of networks. There are various types of networks, and the most popular one are the local area networks, LAN, metropolitan area networks, MAN, wide area networks, WAN. And apart from this, you have many other networks like campus area networks, personal area networks. Particularly Bluetooth comes under this personal area network, and you have body area networks, so on and so forth. We deal with these important first three network topologies. LANs are privately owned networks within a single building or organization used to connect PCs, printers, as well as they can exchange information. In this diagram, you can see there is a central switch or hub, and to this switch, all the workstations are connected. And LANs are distinguished from other kinds of networks by key characteristics: size, transmission technology, and their topology. LANs are restricted in size, normally less than 1 kilometer, and this support speeds up to 10 Mbps, 100 Mbps, and the recent latest one supports up to 10 gigabits per second. Then comes metropolitan area network. A MAN network covers the entire metropolitan city, and one of the examples for that is the cable television network. A MAN is implemented by a standard called DQDB, Distributed Queue Dual Bus. Dual bus, we have two buses here, or IEEE 802.6. And DQDB uses two unidirectional buses. It is a high-speed shared medium access bus network, carry data, video, and voice over a network with bandwidth being allocated as per time slots. So every user, a specific time slot is allocated so that they can communicate with other. And each bus supports traffic in only in one direction and are opposite to one another. The advantage of the paired bus is even one bus fails, other bus can transmit data. You can see in the diagram, A bus is going to right to left, whereas B bus is going from left to right. And the third one, wide area network. A wide area network or WAN covers a very large area, such as the entire country or a continent or the entire world. A matter of fact, the entire internet is based on WAN technology. Part 3, network topologies. A network topology is the arrangement of a network, including its workstations, nodes, and connecting lines. There are two ways of defining network geometry. One, physical topology. Two, logical topology. In physical topology, the actual geometric layout of workstations is described. There are several common type physical topologies: bus topology, ring topology, star topology, mesh topology, tree topology. When it comes to logical topology, it doesn't refer to the physical structure. It refers to the nature of the path the signal flow from one node to another node. In many instances, the logical topology is the same as the physical topology, but this is not always the case. You can see this example. It is actually a common bus topology, physical bus topology. But in fact, the way the signal is moving is a ring topology. And now let us see the bus topology. All devices connected to a central cable called the bus or backbone. You have a common bus in the central, and all the clients are connected using T connectors. This is actually inexpensive and easy to install, but the disadvantage is even a single cable cut anywhere on the bus, it pulls down the entire network. And then comes ring topology. It is connected directly to two other devices on one either side of it to form a closed loop. It is relatively expensive and difficult to install, but it offers high bandwidth and can span larger distances. Star topology, and this is the most commonly used topology in computer labs. All devices are connected directly to a computer or a server through a central device called a switch or a hub. It's easy to install and manage, but if there is any problem with the central hub, it pulls down the entire network. Then comes mesh topology. Each computer is connected directly to each of the others. The advantage is provides an alternative path when a cable cut occurs. And of course, the disadvantage requires a lot of cable, which makes this option very expensive. Then comes tree topology. Number of star networks connected using bus. Main cable acts like a main stem of a tree, and other star networks acts as branches. And you can extend these branches, and this is called as expanded star topology. And the disadvantage is if any root or subroot system fails, its entire connected branch system also fail. Part 4, layered architecture. In layered architecture model, the whole network path is divided into several tasks. And each layer is assigned with a group of specific tasks. You can see in this diagram, layer 1, layer 2, layer 3, so on and so forth. The advantage of layer architecture is one, interoperability between devices from different manufacturers, and greater compatibility between devices, systems, and networks. And of course, the portability. Layered networking protocols are much easier to port from one system of architecture to another. Scalability. Layered or hierarchical design and implementation scales better than horizontal approach. And task segmentation. Breaking a large complex system into smaller, more manageable subcomponents allows for easier development and implementation of new technologies. So these are the characteristics of layered architecture. When it comes to the disadvantages, there will be extra overhead of passing through layers instead of calling a component directly. It has to pass all the layers. Helps to control and encapsulate the complexity of large applications, but adds complexity to simple applications.